So this is geospatial models. It is a means of representing spatially referenced materials. Simplified view of physical entities. So for example, you have in here, the reality is, say, Alaska. Okay, that's the real Alaska. Pretend that's the real Alaska. We want to represent it as an object and attributes. So example, that's Alaska. Then the shapefile is the object. And then the database is the attributes, okay? So the two combined forms a model of reality, spatial model. This is an example of a satellite view of United States. So we want to model it, for example, with a general reference map. So we're modeling the United States is represented as a geospatial map. Types of spatial phenomenon, discrete and continuous. So here's an example of discrete. A lake, okay, is discrete. Continuous is roads. And then continuous, for example, here is throughout space. Temperature is continuous. And elevation is continuous. So a map can represent both discrete and continuous. Organizing geospatial data models. The first picture shows you combined. And then the next one shows you how the data is separated into layers, okay? Attributes. So the attributes is like a spreadsheet. You have rows and columns of information. What you have here is the points. These are the objects. And each point has an attribute and information on the attribute. So example, if these objects have height, so the ID, has height in feet, type, and class, okay? Height. Okay, then data types. Okay, I won't spend too much time. This is just integers, floating, real, text, and date. You can put inside the attribute. So the vector data model comprises of points, lines, and polygons. So what is a raster data model? So raster is a collection of cells, and each cell has a value. So pixel. So this all combination of the raster pixels makes a raster image. For example, then, if you combine all those cells, you get this picture. Okay, and then you have raster resolution. So you have each pixel is quite small or pixel is big. So that's the raster resolution. And then you have also, you can have attribute information inside the raster cells. This box is important, right? So we have raster resolution. The cell size is the resolution. So it could be 6 centimeters by 6 centimeters or 1 meter by 1 meter. Yeah, so the trade-off is the finer the resolution, the bigger the raster file. Yeah? Okay, and the cell coordinates in the center point of the cell. Okay, and the coordinate applies to the entire cell area. And then the bottom one is the raster cell value represents the average, central, most common, and only value covered by the cell. Then the other one is a TIN, a triangulated irregular network. It's usually 3D, surface. And if you zoom in, so you have a point, an edge, and a face. A face is a plane. Okay, if you have a triangle, you always have a flat plane. If you have 3 points in space, it always will have a plane in the space. It'll always be a sheet. 3 points will always create a plane. And you join the faces up, you have basically a surface model. The purpose of this is if you apply colors to the face, you get shading and contours. We'll see examples of this hopefully later. And